A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's lecture will be under the module 12, where we will be discussing about the recycling of bituminous pavements, and more focus will be on hot mix plant as well as hot in place recycling. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, as the term itself says, recycling is putting something to reuse after reprocessing it, after processing it. So, recycling typically refers to the process of recovering any product which we can recover. So, in case of bituminous pavements, it is the already distressed layer which is there. So, we will recover it, we will reclaim it and reprocessing. So, to the process of recovering and reprocessing materials. So, some process has to be there, that and specifically what material we are going to look for it. It is already the materials which have already fulfilled their initial intended function. So, any layer which has already served for the number of years or has shown some premature sign of distresses and failures can be a candidate for recycling. So, recycling typically refers to the process of recovering and reprocessing materials that have already fulfilled their initial intended function in order to convert them into usable new materials for the production of new products. So, for the construction of a new course, we are going to say, if you are using the existing bituminous pavements, by doing some additions to it or by reprocessing the material, then it will be a recycling of bituminous pavements. So, recycling of asphalt pavements involves, what are the main steps involved? Involves the recovery of the existing material, reprocessing it. So, some addition of aggregates, some addition of binder, rejuvenating agent, certain additives are there, and reuse of existing pavement materials. So, by this particular one, we are reusing these materials to construct a 1 or 2 layers of bituminous pavements. So, these materials can subsequently be utilized, and what these recycled materials, what we produced, can be used for resurfacing to say a surface, existing surface showing extensive sign of distresses can be reprocessed, and again as a new surface layer can be laid with that particular material. So, for resurfacing, repaving, putting up some new layers using that particular material, or reconstructing the pavement when we go for a greater depth. So, it is a reconstruction of pavements may be there, and all these exercises will depend upon what factors? It will be first depend upon the existing pavement condition. So, if we will process only surface layer, if the defects are restricted to the surface layer, if the defects are say for underlying base and bituminous binder course also, this has to go down deep to those lower layers also. So, it will depend upon the existing pavement condition. The engineering properties of the reclaimed materials. So, what reclaimed materials we have? We have aggregates already coated with aged binder. So, what are the properties of it? What sizes of aggregates we are able to get? How much coating of binder is there? What is the condition of that aged binder? So, these properties of the reclaimed material will play a role of what we can do with those materials. The selected reprocessing technique and what technique we are using it. So, there are different processes under the recycling also. We will discuss those in upcoming slides. And the specific treatment requirements, and finally what we desire, that is also important, that okay, I want this product by using the existing or by reclaiming the existing distressed bituminous pavements. Now, we have for this particular one, we have IRC 120 2015, which is recommended practice for recycling of bituminous pavements. Along with it, many other codal specifications can be referred in addition to MORTS 2013 specifications for road and bridge works. We have the Asphalt Institute manual series number 20 also on asphalt hot mix recycling. Now, when this process of reclaiming is there, we need to justify that how this process can be good enough. Specifically, what are the benefits one can derive out of the recycling of the bituminous pavements. So, the justification for recycling of bituminous pavements, which consist of aggregates and binder, we can justify it in terms of both economic factors as well as environmental factors. What is the environmental justification which we have? So, the important part is aggregates used in pavements are natural resources, and disposing, if say one layer has distressed, so there is no sense of having that layer, so it needs to be removed, and that particular material, if you are discarding at some place, so you are discarding the aggregates, so you are disposing them. So, if we are disposing natural resources like aggregates, some dump sites after a pavement becomes unserviceable, these not only we are putting these valuable aggregates as a waste, but also it harms the environment, because they are having the coating of binder over there. So, this impact is further compounded by the, and if we are not using it simultaneously for preparing more layers, we are extracting the natural resources or we are utilizing the existing natural resources. So, that way also we are hampering the environment. We are extracting more and more natural resources, which will be definitely create a situation for upcoming generations, a difficult situation where we will be finding in coming years shortage of natural resources. So, we have both the things. One, we are disposing it as a waste, which is not good for environment. Secondly, for we are extracting more of natural resources, that is also not good for environment. So, both we can justify it that we are making use of the aggregates, the existing material present in the distressed layer. So, environmentally it can be very well justified. Economic justification, it says, because recycling allows the reutilization of the aggregates. Aggregates are costly components. There are binder also which is available. So, that is again a very costly component. So, then from the economic perspective, because we are making use of both aggregate and binder, so it can be very well justified in terms of economic operation. So, it thereby reduces the demand for costly virgin aggregates and bitumen. Now, only what the cost may be new is any specific cost involved in the reprocessing of these materials. So, what additional cost is required when you are reclaiming this material or reprocessing that material? So, what we are saving and what we have to add in terms of the reprocessing part, if they can be compared, we can justify it very well. But yes, clearly it is visible that it is good from environmental aspect also as well as from the economic aspect. Now, some of the things which have been put together is specifically here, recycling existing asphalt pavements is to produce new pavement materials leads to significant savings in materials. We can have savings ranging from 30 to 50% of the materials. So, cost and energy, because a lot of energy is required in the extraction of or the production of virgin materials, the crushing of the aggregates, the production of the binder, that involves lot of energy. So, the key benefits we can put up from recycling is the cost savings. This is important. Recycling substantially lowers overall material expenditures in comparison to the reliance on virgin sources of. So, material dependency, as I said, we can use a good percentage of the existing material in the construction of bituminous layers. So, we save a lot of money in terms of the virgin aggregates and binder. Reduce haulage cost, and there are many processes where we can do the recycling at the site itself. We call it as in place recycling. So, there even the transportation of that material, the distressed material, reclaimed material through the plant is also not required. So, transportation or haulage cost is also reduced. Economic necessity is because we are presently, we have a lot of infrastructure to be developed. So, there is always will have a shortage of funds, and In addition to this particular one, the cost of materials, specifically aggregates and a binder, are increasing day by day. So, that is why recycling is very important to be considered at this stage. Conservation of natural resources, as I said, will save our natural resources, aggregates specifically. Saving in aggregates and binder, we will definitely, if we are able to use the existing distressed one, that will save our or will reduce our requirements for virgin aggregates and binder. And this is again definitely in some locations the aggregates may be say available in good quantities, but there may be certain locations which are already having shortage of aggregates. So, there this option of recycling could be a very viable one, because there the aggregates are unavailable, and if you have to get good quality of aggregates from far away places, the cost highly increases. Quality of recycled materials, this may be one concern, that what you are obtaining, is it a inferior quality? No, these materials are having at par qualities to what your virgin aggregates can give you, and even in certain cases they perform better also, because see, if we are using these aggregates which are already coated with the binder, they have already absorbed the binder, no more binder they will absorb, because they have already during their course of time, and whatever reduction in their sizes that could happen under the traffic, that has already happened. So, in certain manners these aggregates may be even better compared to your virgin aggregates. Structure strengthening, because what I am able to do this particular one by use of these materials, definitely I am going to strengthen my existing pavement. So, I am using these materials to put some new layers of bituminous mixes over the existing one. Preservation of pavement geometry, this is again a very important concept. What happens if we keep on putting overlay? It will disturb the geometry, the cross section, the geometrical features of the roads, the roadside elements, the height of the median, the height of the shoulders, the drainage, all those aspects, and even on some of the CD structures it will increase the live load like anything. So, we disturb the geometry also of the road by putting more and more number of overlays every time. So, if we the best part is if we are removing the existing distressed one, which is not adding anything to our structure strength, and then we put up a new layer over it. Some of these recycling processes, as I mentioned, which are done at in place, they even are takes less time, and so the traffic disruption is even less compared to the standard rehabilitation processes, and energy savings, because you are reducing the dependence or the requirements of virgin aggregates and the neat binder. A lot of energy is consumed specifically in their production, as well as if you are doing in place recycling again, and there are methods where we do the cold in place recycling or cold mix recycling also. So, a lot of energy are saved in those options also. Environmentally, this is when we are saving our natural resources, it is always adding the environmental benefits. Now, the 5 major types of recycling activities or recycling technologies which are quite popular specifically are mentioned here. One is hot in plant recycling, hot in place recycling, as I mentioned, something which is done at the site itself is hot in place recycling, something which is done at the plant level is hot in plant recycling. Now, this is, as the term says, hot, so the higher temperatures are involved. Then we have cold in place recycling also, again it is similar to the hot in place recycling. Similarly, we have cold in place recycling, we have cold in plant recycling also, again where the hot mix plant involvement is there, and then there is full depth recrimination also. So, these three are specifically more related to the cold mix technology, and the first two are more related to your hot mix technology. Now, 5 different categories are there which can be worked out. So, there is a requirement to investigate, some preliminary investigation is required to pick up these different kind of recycling options. We will discuss those recycling options. So, in the beginning definitely one need to pick up which recycling option one has to pick up. So, some information about the existing pavement structure is to be required. So, a comprehensive evaluation of the existing pavement structure is essential before selecting any recycling option. So the results of existing investigation of the existing payments are primarily analyzed in three terms. We analyze those investigations. One is payment serviceability, how good it is able to serve the purposes, the extent of surface defects, how the surface defects up to what level they have got extended, and what is the remaining structure strength of that particular payment structure. So when we talk about the serviceability of the payment, specifically that refers to some index which refers the riding quality or user comfort, and when deterioration exceeds certain limits, acceptable limits, recycling becomes a viable option. Now, in addition to other maintenance activities which we have already discussed when we discussed the IRC 82 2015, the different kind of maintenance treatments which are possible. So if these distresses extend beyond a certain limit, recycling becomes a viable option. And as per IRC 120 2015, it says recycling can be considered when the distresses comes under the category of high severity as per IRC 82, when these distresses are considered as higher severity. Second, when the road roughness, so the smoothness of the surface gets reduced to extent where the road roughness is 3000 mm per kilometer, and when the rough depth on the surface exceeds 20 mm, and even all the surface renewals where the surface has to be repaired or the surface has to be improved, they can form a candidate for your recycling. So this exercise needs to be carried out to see what is the extent of severity of the distresses, what is the road roughness, what is the amount of cracks or say the rut depth which is present, and then we can decide what could be a possible recycling option. Extent of surface defect, as I mentioned, this is another important thing which needs to be understood, that it is important to determine whether the distress is limited to the surface course, because it's not that we need to understand what type of distress is, what is the extent of that particular distress, then only a recycling treat option is to be selected. Otherwise, it may not be a good enough, it may not serve the purpose, and that distress may reoccur also. So whether the distress, it is important to understand whether the distress is limited to surface course only, then a surface recycling can be good enough, or has extended to lower layers such as bituminous, and even if the distress has gone down, or if the problem is existing with the granular courses, or even up to the subgrade level, that needs to be understood. So for this you can do the coring, you can cut down the trenches and can see the extent and the type of distress as well as the layer which is involved in that particular distress. Recycling should preferably match the depth of, because we will prefer to go up to that particular depth, the layer which is having the problem. So if confined to a bituminous basis, recycling combined with a strengthening overlay, if there are no significant distresses in the underlying course, it is mainly confined with the bituminous courses, then we can go for the overlay, and if the surface one has shown an extensive sign of distresses, it can be recycled. Along with it, an additional overlay may be provided over it. If extended into granular or bound courses, if it goes down into the granular courses, then what we can do, because if an improvement is required at those granular courses, we can reclaim the bituminous materials, and that the lower one can be, whatever your bases, can be pulverized, stabilized and relaid with the, again with the overlay of bituminous overlay, using those reclaimed bituminous materials on the top. Structure strength, as I mentioned, this is another important aspect which we need to work it out, that how much is the current strength, for how many more number of years the existing pavement can serve. If it can serve a purpose for a good number of years, say 4 or 5 years or more, then we can work out by just providing an overlay also. So if a structure evaluation indicates that the pavement has sufficient residual life to withstand traffic loads, say for the next 5 or more years, recycling may be limited to the surface layers only. Only that the top one which has shown some distress can be a candidate for the recycling. However, if the pavement doesn't shows adequate structure capacity, then the recycling should be combined with a strengthening overlay. So even the recycling of the surface course has to be followed by an overlay, properly designed overlay for the strengthening, so as to ensure a long term performance in that particular case. The next important method aspect in recycling is the removal of the existing pavement. So basically this removal of the existing bituminous pavement is quite often done by two popular methods. One is the milling and second is ripping with subsequent crushing. These are two quite popular methods which are used for reclamation of the existing bituminous pavement to get this reclaimed asphalt pavement for our recycling purpose. So we will discuss these two methods, milling as well as the ripping and subsequent crushing which is there. So milling is the controlled removal of the existing pavement to a specified depth using specialized equipment. That is specialized equipment we call as a milling machine, fitted with replaceable tungsten carbide cutting teeth. This is a pic of that particular milling machine. You can see this drum is there, a rotor drum is there, which is fitted with these teeth which are replaceable. So fitted with replaceable tungsten carbide cutting teeth mounted on a rotor drum powered by the milling machine. So this is a typical milling machine. Now with this particular one, you can remove the surface to a predefined depth and you can give a camber also to that particular one. So it has various advantages. Because of this milling machine, the recycling has also become quite popular or easy to do in that case. It is the most popular way of reclaiming the bituminous pavement material. It is mostly used following a cold process, and that's why many a times you will find that milling, they mention it as cold milling. So because it's a cold process, mostly done following a cold process. Now cold milling of existing asphalt pavement is usually carried out. Under what circumstances this can be widely done? To improve the rideability, skid resistance and the cross slope. If say there are some minor depressions are there, or some issue is there with the cross slope or camber is there, or the surface has become very smooth, specifically the top surface, and so these are some challenges related to your surface course only. So if you can mill to a slight depth of your surface course, and that surface can be corrected for your grade, camber, as well as will give you enhanced skid resistance. So this milling operation can quite often used to improve the skid resistance and the camber of this road surface. To lower the finished grade adjacent to curb or shoulders prior to resurfacing. Many a times what happens whenever some overlay is required, resurfacing is required, and you are finding it out some previous overlays are there and they are not as per grade. So in that case, with this milling operations, we can bring that existing surface to a required grade, so as to maintain a proper height with respect to your shoulders, medians, curbs. So this is another advantageous feature for which cold milling is widely popular. And the third one, especially the complete or partial removal of any particular layer, any particular distressed bituminous layer. Here you can see this particular one has been removed to a given depth. So because it has been observed that this top layer of the bituminous pavement has completely distressed, so this milling machine operation has been carried out to remove that particular top layer. Now once this reclaimed asphalt material is there with us, or the wrap is there with us, it is usually either in one process, if it is used at the site itself by hot in place recycling, or many a times it is transported, stockpiled at some location, and then whenever it is required, it is used. So the work of cold milling can also include the transporting, stockpiling and otherwise disposing of the removed pavement material at some suitable location. Now cold milling requires specialized machines which are capable of achieving precise depth and cross slope. This is important. And what are the common key features of this? Is a pic of a cold milling machine. You can see the surface is getting milled, and from this chute this is getting moved to this particular tipper, and then it will be transported where it is going to be stockpiled, and we can see the surface after it has been milled out. So Adjustable cutting capabilities have to be there with these milling machines. So, whatever required depth up to which you are observing any distress and the surface needs to be removed, this milling machine should be able to do it by maintaining the cross slope and the proper camber also. The dimensions should be good enough in that particular case that we are able to go for good widths, say typically 2 meters. Normally you have these ones of 2 meter, it may be more than a lane. Also nowadays milling machines, more robust milling machines are available. And advanced mobility, that's also the feature, because when it moves over the existing asphalt pavement, it should not damage the existing surface. So that's why their tracks are fitted with track pads specifically, so as to avoid any damage to the existing pavements. And then since a lot of fines dust are generated, so there should be a system to control or minimize this dust. You can, this is a covered chute is there. So the dust generation, so as to, first of all, it is important that less amount of fines or dust are generated, because that will limit your use of this wrap during the recycling also. And then from the environmental aspect also, it is important that there should be provisions for reducing the any pollution which is happening from the dust emissions which are taking place during the milling operations. Now the second one, the second method which is popular for reclaiming the bituminous pavement or even the lower layers of the pavements is ripping and crushing. And it is an alternate method to cold milling, involves ripping and crushing. And the key features of this particular one, what type of equipments can be used? We can use scarifiers, grid rollers, or rippers are there. You can see this is a ripper which is doing. So it's breaking the asphalt material, especially the one which has been distressed. And then this particular one, because you can see big chunks are there, so they need to be transported for crushing operations, because they have to be brought to the usable sizes. Now what type of equipment we can use to crush this existing pavement? See, this needs to be decided on the basis of what big sizes of these chunks can be accommodated during the crushing operations. So if smaller chunks, we have to look for something which gives smaller chunks so that it can be accommodated into your aggregate, into your crushers. Suitable for roadway upgrades or small projects, specifically quite suitable when small projects are there or where it is difficult to have a milling machine in that particular case. And when we are requiring to go for greater depths, we can go for these ripping and crushing operations. Retrieved material needs to be, now here important aspect is, usually because the chunks are of variable sizes, so it needs to be crushed, sieved, separated, and then it needs to be stockpiled. And even if granular, if you are going deep into the underlying layers also, where the problem is existing with your granular courses, then again with this ripping you may have to bring those bigger sizes. So the crushing operations along with the pulverization may be there when we are dealing with the lower layer materials. So now once you have this the reclaimed bituminous material with us, or the material from other pavement materials layers, then we will go for the recycling one. So here we will discuss the two most common recycling operations specifically with the bituminous layers. The one is hot in plant recycling. Very popularly it is also known as hot mix recycling. So that the word itself says that it is the recycling which takes place at the hot mix plants. So hot in plant recycling is the process of producing and laying hot mix asphalt using a blend of what? The reclaimed asphalt pavement material which we have, the wrap which we got from the milling operations or ripping and crushing operations. This is having already coated with aged binder. The binder which is already there over the wrap is in an aged condition, mixed together with virgin aggregates and virgin binder to meet the design requirements. So the design requirements will be what we are expecting from a virgin mix. We will expect the same requirements from this recycled mix also. Design requirements maybe in terms of air voids, maybe in terms of stability are same, because we are going to use it as whatever requirements are there. If that particular mix is used as a base course, binder course, wearing course, so what requirement are there with your the virgin mixes, same will be there for your recycled mixes also. recycled as most of the time they are same to your virgin mixes, and this recycled mix can be produced using both batch type and drum type hot mix asphalt. There are some key considerations, specifically this hot in plant recycling when done with batch type and drum type plant. We will discuss both of them. Hot in plant recycling generally follows the conventional hot mix production process. It is usually the same, but some specific key differences are there, or key provisions are there when we are attempting this hot in plant recycling. One is, instead of using only fresh aggregates and bitumen, RAP is incorporated in case of this recycled mixes, and a typical percentage of this hot in plant recycling or hot mix recycling is around 30%. It is a typical percentage. For some plants, batch type plants, it is slightly lower. For drum type plants, it is slightly higher. Rejuvenators are added. This is another important feature in during this the production of the recycled mixes by these batch type or the drum type plant, that rejuvenators are added, because what the binder which is present in the wrap is a highly aged binder, so it needs to be rejuvenated. So for that particular one, different kind of rejuvenators are popular to restore the aged binder. And third is, unlike virgin aggregates, wrap is not directly heated. This is an important feature, because there is a binder which is already presented, so it cannot be directly heated in the same manner as we do it for the virgin aggregates. Otherwise, this binder will get further aged. So in case of the virgin mixes which gets produced through the batch type plant or the drum type plant, where the aggregates are directly heated, in this case a wrap is not directly heated. So, is not directly heated at high temperatures due to the risk of excessive fume generation and the excessive aging of the binders. So, these factors are mainly, now how these factors are taken care? These factors are mainly managed by modifying hot mix plant. Some amount of or some typical modifications are popular for both the type of plants, so as to specifically in the concern related to the feed of these wrap to these plants, and by making necessary adjustments to the production process. Some necessary adjustments are there. We will discuss these for both with the batch type plants and for the drum type plants. So, first of all, hot in plant recycling or hot mix recycling using a batch type plant. So, what type of modification can be there? How this wrap can be prevented from a direct heating as in the case of the virgin aggregates. So, hot recycling utilizes the heat transfer method. Now, this is the important feature which has to be taken care to soften the wrap to permit mixing with the virgin aggregates and asphalt binder and recycling agent. So, we need to have some heat transfer from the virgin aggregates heated to higher temperatures. So, from the conduction of heat from these superheated, we can call them superheated virgin aggregates, the wrap will be raised to higher temperatures, so that aged binder becomes soft, and then the mixing can be there with your new aggregate, with your virgin bitumen, as well as with your rejuvenating agents or recycling agents. See, the most widely method used of specifically in batch type plants is the maple wood method which is there, and this maple wood method is specifically popular because this was first tried in maple wood, Minnesota in USA. That is why it is quite often known as a maple wood method which is there. And what is specifically done in this maple wood method is, virgin aggregate is first superheated in the dryer. So, here we can see a pic of batch type plant. So, we have the aggregate dryer, from then we have the elevated hot screens are there, hot bins will be there. So, here the virgin aggregates which are to be used are superheated, and then this particular one is to be transferred to the hot bins, and then when it comes to the weigh hopper, there will be introducing our wrap. So, this will transfer these superheated aggregates virgin aggregates will transfer the heat to the wrap in the weigh hopper, which is at ambient temperature. So, a separate wrap bin supplies material via, this is a wrap bin and this is a conveyor belt for it, supplies material via a conveyor belt to the weigh hopper of the batch plant which has already been charged with superheated aggregates. This is important aspect. RAP when deposited on the, so once you have the superheated virgin aggregates over which the RAP gets deposited, so the RAP becomes warm and the heat transfers warms the RAP and further heat exchange. So, the heat exchange takes place, a small amount of mixing is done with the superheated aggregates and then later on again the heat transfer is there when subsequent wet mixing is done with the binder also. So, that is why this is how specifically this slight modification is there in batch type plant, a very popular modification is there to introduce RAP so as to provide to restrict the direct heating of the RAP. Now, this because we are introducing it to the level of the wave hopper and this RAP is getting warmed through the superheated aggregates. So, there are limitations on how much percentages of RAP can be used in a recycled mix. Some of the concerns which controls or which are key contributing factors on the percentage of RAP which can be used in the recycled mixes specifically with batch type plant. One is moisture content of RAP. So, if moisture content of RAP is more, the production capacity is because you need more amount of heat transfer to bring those RAP aggregates to the desired temperature and to remove any presence of water from it. Temperature of the superheated aggregates, there is also a limit up to what temperatures the natural aggregates can be heated. So, that superheated temperatures, depending upon that we can also use, because if more percentage of RAP has to be introduced, then we need to heat the remaining percentages of aggregates to more higher temperature. So, this is also an important aspect, that up to how much temperatures the virgin aggregates can be heated up. Temperature of the RAP, this is another concern finally, because is it at ambient temperatures or it is a very cold season may be there, and during cold seasons the temperatures may be quite low of the RAP. Target temperature of the recycled mix, at what temperature. So, if we are using say certain additives by which the temperature they can be compacted with at low temperatures, they are good enough. And another concern is how much percentage of fines are there, because through milling operations usually more amount of fines are generated. So, that further restricts how much percentage of RAP can be incorporated into the recycled mixes. And in practice around 30 to 35% of RAP is usually considered as a upper limit, but typically through batch mix plants you go for a percentage of RAP in the range of 10 to 20% at most of the batch type plants with these small modifications which are required. Now, the other type is the hot in plant recycling, specifically with the drum mix plant. So, the first one where we discussed the modification was for the batch type plants, here for the drum mix plant. Now, in this case also RAP cannot be directly processed in conventional drum mix plant, because as we do for the virgin aggregates, because a direct contact of this RAP with the burner flame produces excessive blue smoke which is harmful for environment also. This issue is further aggravated by the building up of fine aggregates and bituminous binder on the metal flights and end plates of the dryer of the drum mix plant. So, that is why a popular method of modification is the center entry method, which is there, is the most widely used technique for hot mix plant in drum mix plants. And what is done in this process, RAP is introduced into the drum through a collar located downstream of the burner flame, where it is blended with the superheated virgin aggregate. So, you can see this is a drum mix plant is there, this is the flame which is there, this is the virgin aggregates which are entering, and on the downstream this is the point from where your RAP is getting introduced. So, this RAP will be heated through the already superheated virgin aggregates. So, there will be a wheel of virgin aggregates which will be there, these RAP will be not directly exposed to the burner flame, and then you have the regenerating agent or along with the binder which is to be there to get the recycled mix which is getting produced. So, this is again a modification which is quite popular specifically with the drum mix plant. So, hot in plant recycling using drum mix plant. The hot virgin aggregates transfer heat to the RAP material primarily again through conduction. Now here also how much percentages of RAP can be typically used in drum mix plant will depend upon the moisture content of RAP, ambient temperature of RAP as well as virgin aggregates, desired production rate, because you need to give some time for the transfer of heat from the virgin aggregates. So some more amount of time is required for mixing this your virgin aggregates with the RAP, and finally the mixing with your regenerating agents and the virgin binder. Target temperature of the recycled mix, if that has to be high, then you need to have more time and you need to have more the virgin aggregates heated to more higher temperatures. But the typical percentages usually recommended is around 30%, ranges can be 30 to 50%, and with some more modifications higher percentages has also been tried, but a typical percentage is around 30% for the recycled mixes through the drum mix plant. Now many a times these drum mix plants are more preferred for the recycled mixes, specifically because they are portable. They require a shorter period for their installation. They are portable compared to your batch type plants. Versatility, because you can make these modifications much in a easier manner compared to how you require in your case of batch plants, and then you can accommodate, because at way hopper, as we have seen in the case of batch plant, there is a limitation how much amount of RAP can be introduced, but that particular limitation is less in case of the drum type plants. Production capacity normally up to a certain percent doesn't gets affected specifically for the drum mix plants. And mixing quality, because you can in this particular one it is blended with the virgin aggregates and it is easier to maintain the mixing. You can add on to the mixing time, you can give more amount of time when these virgin aggregates can be, depending upon where you are introducing the RAP into it. So on the basis of your design of your drum mix plant, you can even get good quality of your recycled mixes. So these are some key features because of drum mix plant are more popular in hot in plant recycling compared to the batch type plants. Now the other common recycling technique is your hot in place recycling, or we can say on-site recycling, which is there, and this is again to rehabilitate deteriorated asphalt pavements while minimizing the need for new materials. Here specifically when we are targeting some surface layers which can be easily modified, the distresses are restricted to the surface layers, this hot in place recycling is quite popular. So the main steps involved in this particular one, because it has to be done at site itself, is first to heat the existing asphalt surface to soften it, and then it is scarified, because we have to remove the distressed layer. So scarifying or mechanical remover of the softened material layer. Now this softened material, if it is short of say binder, short of a particular size of aggregate, or inadequate binder is there, binder is highly aged, so depending upon that we can add the virgin aggregate, virgin binder, or even a virgin mix to this particular one. So blending with reclaimed material, usually with a recycling agent, new binder, or even a new asphalt mix which is there, and then followed by laying and paving the recycled mix back onto the pavement surface. So all this needs to be done at on site itself. So in hot in place recycling, a train of equipment is usually employed to perform, because these are multiple operations which are to be performed together. So sequential operations, what it includes, infrared heating to bring the existing surfaces to a desired temperature, and thereafter the pavement surface needs to be milled off or to be scarified, conveying the milled material to the pug mill mixer, where it is transferred to the mixer in that particular train itself, and adding fresh mix or fresh binder or regenerator agent as per the design requirements. For thereafter this mixed one recycled mixed material is to be discharged through integrated paving skids which are integrated in this particular equipment, and finally rolling and compaction of the recycled layer is there. So this is what are the key features of hot in place recycling which happens, or we can call it on situ recycling. So this is a big train. It is a set of equipments in line which are there. So we will have the key considerations in hot in place recycling. At what temperatures the pavement needs to be heated, up to what depth it needs to be scarified, collection and conveyance of reclaimed bituminous material, RBM, which is to be there, addition of regenerators, fresh mix, fresh binder, fresh aggregates, and thereafter followed by paving and compaction. So a hot in place recycling equipment can either integrate all these functions within a single unit. So you can see this is a single unit, or employ a synchronized train of equipment. So one single equipment may be there, or there are synchronized unit is there. One unit is doing the heating, second unit is doing the scarifying, the third unit is doing the mixing part, and the fourth unit is giving you the mix through the paver, the screed which is there, and finally your rolling and compaction. So it can be a single unit, or there can be synchronized units may be there, which works in all together. So good control is required over heating, specifically material feeding, mixing and laying operations. Hot in place recycling may be carried out as a single pass process. Single pass process may be there, in which case you have produced the recycled mix, where a scarified material is compacted in a place and you can compact it, or in a multiple pass process is there, where over this particular one you can put up a new fresh mix also, and then it is compacted. So there may be a recycled mix layer followed along with a layer of a fresh mix also, and then they may be compacted together or individually. So typical treatment depths. This hot, because this heating has a limitation, so typically this hot in place recycling or hot in situ recycling is done for depths of 1 to 2 inches. So in that case we can consider it is basically restricted to your wearing course or surface courses also, and the temperatures which are usually achieved are in the range of 110 to 150 degrees centigrade. This is a small sketch which shows how the process is there. So we have these infrared heaters are there to heat the existing surface. Then we have these scarifiers which are going to remove the softened pavement surface to a desired depth, and then we have the first mixer where you are going to add the regenerating agents and it is going to mix here. Thereafter, depending upon the requirements of the mix, if it is falling short of a certain particular range of aggregates, or the binder or aggregate or even a new mix can be added and it is mixed in the second mixer. So it depends upon what type of the recycling unit it is, and thereafter you have the screed which gives you the desired thickness of. So initially what thickness you have milled up and what final thickness you are having it, which is later on compacted. So this is what the benefit of the hot in place recycling, because all this process is getting done at the inside itself or in the in situ itself. So hot in place recycling offers following key advantages is road elevations and overhead clearances are preserved, because you are not increasing the more or less the thickness doesn't get increased, only a small variation may be there depending upon the lack of materials which were falling short. So on the basis of so you can see this is a different units working all together. You have these propane heaters which are there. So here also you can see, so it can be one unit or different units working in synchronization with each other. Process comparatively quick and economical, because there is no any transportation, hauling of material which is required. Everything is done at the site itself. Aggregate gradation or bitumen content of the existing asphalt surface can be slightly modified, because depending upon the requirements we can modify the aggregate gradation as well as the asphalt content. Surface frictional, because with the modification in the aggregate gradation definitely we can achieve a surface with having a more higher amount of skid resistance. And since this is done at the site itself, there is no bringing of mix, there is no transferring of wrap to the field, the hot mix plants, and then bringing up the recycled mix to the site. So all these activities are not involved, and that's why this particular hot in place recycling is having less traffic control requirements and the delays. But yes, this is more or less restricted to top your 1 to 2 inches of distresses, where this can be very well done. So these are some of the recycling methods which are under the category of hot in place recycling or hot in plant recycling. Thank you so much.